Hi everyone, I'm very pleased to host this webinar of ISC on the HPC and AI conversion in ATOS to support the scientific application. So my name is Cédric Bourrasset. I'm working at Atos. I'm in charge of the AI business for the HPC business unit, and I'm also a product manager in ATOS. Just before going into the detail, one quick overview of who we are in ATOS. In fact, in HPC today, we are #1 in Europe and India and South America, with a lot of customers and also a couple of experts everywhere to support our customer. Meaning that this number means that we have a global presence in HPC business, with many different use cases in HPC, and we are seeing a very important trend we'd like to support, of course, which is a convergence between standard HPC and science application with machine learning. And we have seen in the market a couple of years ago that there is some factor driving this convergence between simulation and AI. The first thing was we saw that the rise of the performance of the processor was smaller than before. I mean, everyone knows the Moore laws, so on the HPC side, so that's quite admit that things are slowing down. And on the other side, we saw that the rise of machine learning solution that can benefit and provide to the science application by integrating some new machine learning techniques in order to speed up the simulation. So we saw also that the compute power which can be provided by HPC system can also benefit in the other way to the AI, which requires more and more compute power. So we saw that there is these two trends on how the machine learning can benefit to science application and how the HPC supercomputer can speed up also the AI research. So we decided in ATOS to set up a different project on this convergence between AI and HPC. The first one is about infrastructure, or we can provide to our customer a converged infrastructure between HPC and AI needs. So for this, we have developed, of course, an hardware platform, Bourrasset H2000, which is our high-end platform for HPC, and we integrated huge AI capabilities. And on top of it, we started a couple of years ago also to develop software that enables the AI on large-scale HPC infrastructure. So that's one of the first track and development we have in ATOS. The second one is about how we can develop AI-driven optimization tool, or we can enhance an HPC production using machine learning techniques. So we integrated and developed a set of tools and software products to enhance the production of our customer into our system. It's possible to do that on many different angles. Today we are working on the energy consumption, on reducing the data movement on the HPC system, and on optimizing job placement and resource allocation. The idea is to be able to optimize the TCO of a production system by using AI. And the third pillar we have is about supporting our customer to apply and to put machine learning solution into their science application. So we have started to do some research development on some specific use cases, and on the other side we have a complete portfolio of data science services that can be applied to any science application. So we are able to support any customer on any of these science use cases across the world. In terms of scientific development, today where we are and where we are making research and development, we have a couple of use cases that are supported and connected to some of our customers. The first one is about working on CFD application and body force use cases, where we replace a part of the equation into the CFD by a neural network that is trained to surrogate the behavior of the engine. So that's one of the first key use cases we have is about bringing surrogate modeling into CFD application. The second use case the Atos AI research team is working is on autonomous driving. We have very good partners and customers on this field, and we are seeing also that there is a huge need in terms of simulation about autonomous driving. So we are working closely with some software vendors that are able to provide simulation tools to autonomous driving, and we enable them into large-scale systems. So our mission and contribution there is about orchestration of mixed AI and HPC workflow, and developing some neural networks on autonomous driving. The first use cases in domain we have put data science in place is about weather forecasts. We have a couple of customers that are providing weather forecast. We provide weather forecast solution in Europe and in the world, and it's a key market for the future to be able to enhance weather forecast and climate change. And we have a couple of projects running on how we can use, how we can optimize the parameterization scheme of the simulation, or we can mix machine learning based solution with a classical weather forecast application, not optimizing a simulation kernel, for example, but more bringing direct machine learning models and deep learning models for weather forecast. The fourth domain we are making research and we are working a lot is setting up a center of excellence for life science. And in this center of excellence, there is many use cases on using AI, of course, for molecular discovery, for example, on our HPC system. So here you have the existing scientific development we do with some of the customers to provide them expertise on which are the best model to use for this use case, or we can do some model design, or we optimize the trainings, or we deploy the workflow in production on the HPC system, and so on. So with this research program we have, on top of it, we have built a kind of high-level services we are able to provide worldwide, helping our HPC and research community on AI, because we saw that some of the competencies are very important, like, for example, or we can help you or customers to distribute the AI into a large-scale system. Or we can work on, for example, data exploration, or we can optimize the pre or post-processing based on data analytics, or we could help to industrialize machine learning solution, because it's quite different between machine learning and classical science application, and so on. So we develop a complete set and a complete program of trainings, labs, workshop in Atos to support all of our customers into bringing some expertise. So that's one of the key assets we can bring to the science world to bring some AI specific person. In top of support and science, we also aim to provide the compute and data part. So that's key for us as a end-to-end solution provider to bring science, support, compute, storage, and it's today on our side based on, for example, on the data part, we are partnering a lot with DD and storage on how we can use their AI appliance at a large scale for having a mix of HPC and AI workloads on the same system. We also have put in place our own product line for storage called Bourrasset Store, On the compute side, so I mentioned the Sequana XH2000. We're also working with NVIDIA on pure large-scale AI system based on NVIDIA DGX SuperPOD architecture. And that's key for us, to be able to bring the data, to bring the compute, and to bring the people to our customer. Bullix from the hardware and compute point of view, the idea of our solution is quite simple, is that we have a very high-end servers that are available for HPC, that you can mix the blade between standard HPC blade for CPU and dedicated AI blade. So you can have a very flexible way to mix the compute power depending on the production you're going to have on your platform, the workload you're going to have, and the ratio between CPU blade and GPU blade you will need to have. So we have just launched a new blade called Bull XH2415. It's based on the new AMD technologies and the new NVIDIA Ampere technology. So you're going to have two AMD processor and 4 NVIDIA A100 on the same blade, and you can put 2 interconnect mechanism board, either with InfiniBand network or on interconnect named BXI. So everything fits in one new blade, full DLC blade. So you have a very dense solution to bring a huge AI compute power into your simulation. And as I mentioned, you can mix the blade between a standard HPC, for example, standard CPU blade, plus this AI blade, for example, in the same switches. So you're going to have a mix between CPU and GPU capabilities into the same platform that is very flexible and that allow to scale at a large scale. Another compute solution that is more related to large-scale AI solution, which is the NVIDIA DGX SuperPOD. So we are partnering with NVIDIA on this for the European and the Indian market, where in fact SuperPOD architecture is clusters of NVIDIA DGX servers with a non-blocking Mellanox FAT3 topology, and you can put some dedicated AI storage appliance. So Atos is a provider of this solution, large-scale AI solution that also can run some HPC workloads, and we bring on top of this the capabilities first to deliver and to design, to optimize the design, but also to secure and have a multi-tenant access to such infrastructure. So we bring software to add security on top of the SuperPOD for enabling multi-user and multi-tenant access of such system. We have built also a dedicated AI software to handle, I would say, the standard machine learning workflow from data collection to training, model trainings, model deployment, framework management, data management. And we bring security feature on top of it to enable multi-user access to such large-scale DGX system. And also from a pure solution, we're able to do some managed services to bring some of our data science and research capability to any of our SuperPOD customers. So basically the expertise on science application we have, we can bring to any of our customer and setups of some joint research centers in any of the country we are present, and also center of excellence can be done and set up around this offering. So what is interesting in SuperPOD is that we have designed and delivered the first SuperPOD worldwide in Atos. It was for the University of Oxford, hosted at the STFC in the UK, and the idea of this project was to provide national machine learning and deep learning services for the research in the industrial community in the UK. So that's the first SuperPOD we delivered 3 years ago, which was key for us to, be able now to show that we can operate this kind of system for 3 years. So it's a very good reference. On top of the SuperPOD itself and on top of large-scale AI solution, we bring software, which is key, in fact, to enable the AI into HPC system. And we bring our own software named the Codex AI Suite. We have inside this set of products an ML engine that has been designed by Atos that is compatible with the HPC world by having a connector to HPC job scheduling. And it's also compliant with all the framework optimization that are done by our partner like NVIDIA on the GPU. So we benefit from the optimization, and we bring security feature on top of it to ensure that the operation will be secure in production. So to bring authentication, to bring security feature on top of some of the open source software that are available on the community. When we are dealing with HPC AI, at some point we need to tackle workflow management and workflow issue, because what we are saying is that even if we have started to do some research on, what could be the best model for these use cases, or we can do surrogate modeling for this one, what kind of hyperparameter strategy we should put in place. At some point in production where we will need to be able to handle the capabilities to deploy a science application with the capabilities to deploy the machine learning trainings and the machine learning inference that will surrogate a part of the simulation. So we have set up a specific libraries, and we are working on an orchestration side in order to enable this HPC AI orchestration capabilities and to be able to manage this different life cycle of application in multiple environments. So this orchestration its name is YORC. It's totally open source, available on GitHub. We just released the version 4.0, and we are using it for a CFD use cases where you're gonna have, for example, a CFD application with SU2 coupled with a machine learning model that we train on our own system. So we will, for example, deploy the simulation on some compute, deploy the machine learning, which expose an API, and work on the coupling of the two in production. So it's a very usual workflow between the model trainings, starting from the physical data, and to be able to deploy the surrogate modeling. So we have built the first software libraries that is making the life easy to the research people to deploy such hybrid workflow. Storage key also to bring performance at a large scale for AI. Today our main partner is DDN, which is able to bring very high level of performance at large scale for AI. So we are basing our SuperPOD and our HPC-AI solution based on the DDN storage, which is a very key partner for us, and also which can at some very soon bring some GPU direct access to the storage, which will be very key to continue to grow in performance for AI at a very large scale. As in conclusion of this talk, I just want to highlight the fact that this convergence is moving forward. More and more scientific application are integrating machine learning and AI into the workflow. So in Atos, we are ready to deliver the hardware and the software. We have already developed the AI tools to enhance the production automatically on the platform, totally transparent for the developers. And we are here and we are bringing research and engineer to help of our customer for integrating machine learning in the application. Can be on the workflow side, can be on the surrogate modeling side, can be on any other new research topic we could have for science application. It ends this webinar session. I hope you have learned something about our capabilities to support the HPC market. Here you have my contact if you need more detail or if you have questions. Thanks, and talk to you soon.